You've already had some experience creating and using variables in your programming. But what if you needed a whole bunch of variables, and the variables were all related in some way, like a set of names, or teams, or scores, or addresses? Is it really necessary to create a variable for each and every one? Fortunately, no. In this lesson, you'll learn how to create just one variable and store many items in it. You'll learn all about creating a list in Scratch.
To finish this unit out, let's get back to programming, back to actually doing something in Scratch, and learning about a new type of variable, which is the list. You'll see this as part of the Unintendo controller project. In that project, you'll track button presses on a game controller, and they'll be coded as bit strings that a player enters. And you'll also see this topic of lists as part of the APCSP exam in the pseudocode questions. You will probably also want to use these in your create task for the AP exam, or, it's a possibility that you could. All right, just so that you can see, this is what you will get on the reference sheet for the exam with regards to lists. And you can see that this letter I talked about the letter I before when we were using for loops. And actually, surprise, surprise, you see that once we've gotten to lists, we do actually have a for loop in here. And I'll be talking a little bit about how that looks in Scratch and how it's different for the APCSP pseudocode. But this letter I typically is the index of the list. Okay, or sometimes I think of it as the item. Which item are we at? But index, I think, is probably the more correct term for that. You'll see that with lists, you can reference a specific item in the list. And that's what that code right there is referring to. You can also assign a value to a list item. So this one right here shows that we are assigning whatever list item J is, whatever word or number is at that list item, we are actually assigning that as the value of list item I, the one that we're on, the index. You can see that a list can be set to not one specific value, but multiple values. That's the whole point of a list after all, right? So we can actually assign like 3 or more, however, multiple values to a list. And that's what that part is showing right there. All right, and then the last part here is that you can actually process a list. You can work through a list by cycling through each of the index numbers in order, okay? And just remember that on the APCSP exam and in Scratch, which is nice, so at least it's consistent for that part of it, the first item in a list is number 1, okay? In other programming languages that it's not the case, but it is number 1 in this case. So the first item in the list is number 1. Let's move on to seeing how lists look in Scratch. All right, so you are certainly familiar with lists. You probably have some sort of a to-do list, which is like a list of things that you have to accomplish today or tomorrow or within the next week or whatever. You probably make a grocery list before you go to the store so that you know what you need to get. So you're familiar with lists. In computer science, a list is a data structure. It's actually an abstraction as well. Okay, so it's a form of data abstraction. So it's a particular way of storing data. And for us, it's a way of thinking about multiple items in a list, to think about a list as multiple points. It can contain many objects. Lists are ubiquitous data structures in computer science. And ubiquitous, if you're not familiar with that SAT word, just means they're found everywhere, because any computer program nowadays has to use lists in some way, shape, or form to keep track of who is using it, of what people have done in a certain game or app or whatever. In Scratch, you're able to make lists under the variables section, okay, because they are an example of variables. All right, and so on the screen, you can see just a quick script that incorporates some iteration to populate a list. And so you can see that the list starts off and it is empty. You don't see any of this stuff up here, and it will say length 0. So when you create a list and before you've added anything to it, it's empty and has a length of 0. This script works to iterate through a couple of steps, a sequence of a couple of steps, and repeating that process until the length of list is equal to 5. And the process is Scratch Cat will say name a fruit, and then you type in the name of a fruit, and it's going to do that until there are 5 fruits in the list. No, there is no check right now to check and see if they're typing in something other than a fruit, like an animal or something else. But, all right, and then at the end of it, it says it will say fruits, and we know that's display. All right, so it's going to display the value of the list. Well, the value of the list is 5 different things. And so this is what it's going to look like right here when Scratch Cat says list, the list of fruits. All right, so Scratch is really nice, and it separates all of the list items out with a space. Sometimes when you do this, when you want to display a list, sometimes it will separate itself out with commas, but sometimes it won't be that nice. It'll just be lists, and you'll have to actually use concatenation to separate out the items. So with anything new, the first thing you want to do is explore, play around, see what you can do with lists. You've got a nice start. You can go back to the previous slide and kind of use that as an example to populate your list. You can make it as long as you want, for as long as you would need your list to be. And you'll get a chance to do this all in the Try It Out section below.
Hey everyone, Mr. Levin back again, and guess what? We're talking about abstractions again. This time though, we're not going to be talking about abstractions as a general concept. We're going to talk about how abstractions in lists can be a way to represent an idea in the real world in a programming environment. Let's check it out. Okay, so now that you have seen in this lesson how you can use lists in your programming in Scratch, we're going to talk a little bit more about why we consider a list a data abstraction and why that might be advantageous when you're writing your programs. So for this example, we're going to look at a list of 4 items. The first word is Scratch, second item is the cat, the third item is a number, this looks like a phone number, and the fourth item is an email address. So for the computer, this list has 4 items, item 1, 2, 3, and 4. Right? And when it represents a list, it's just seeing these as a list of items or values in order. And each one of them can be referenced using the unique index, item 1, item 2, item 3, or item 4. But for the programmer who wrote this list, they would actually consider this not just a list of 4 items, but a list of contact information. And each item on that list has a specific purpose. Right? So the first item would be the first name of the contact. The last name would be the second item. The third item here is a phone number. And the fourth item would be an email address. So the reason this is called a data abstraction is that instead of the programmer having to think about what is item 1, what is item 2, and think about where those items go on the list, all of the details of the implementation, they just have to think about the details of what that information represents. Just remembering that first item is first name, second item is last name, and so on. So data abstraction makes it easier for the programmer to keep track of how they're storing contact information. It also makes it easier for other programmers who might want to use this same data structure and build on this to make more complex programs, such as a list of contact information that you might use to store all of the contacts in your phone. So here we have the same implementation in Scratch. You can see that we have a list with the 4 items on it, and we can access each of those items, item 1 or item 3, just using this one block that says item 1 of contact. And the benefit here is that contact is now the name of this list. right? So instead of having to store all 4 pieces of information as their own variables, we're able to store this entire list of information as a single variable called contact. And you'll notice that this list has several different types of data on it. And that's another of the advantages of a data abstraction, is that it can group together things like the string representing first name, a string representing last name, and the phone number as an integer or as some other type of number representation, and then this string that has special characters in it. We can store all of those different types of data in one data abstraction that we're calling contact here. Right? This development of a structure called contact, or an abstraction, is something that you can use to develop a larger program, right? So we talked about this idea that you might make a list of contacts. That's going to be a lot easier and much easier to maintain if every contact has the same structure. It also means that it's going to be easier to work with this data structure because now we know that every contact that we encounter has the same structure. Item 1 is the first name, item 2 is the last name, item 3 is the phone number, and item 4 is the email address. So the use of a list as a data abstraction is one way that programmers are able to build more complex programs by first creating data abstractions that hide some of the implementation details of the smaller pieces of their program and then building on those abstractions to make more complex programs. Hopefully you'll be able to use this in your programming going forward.
All right, now that you've had a chance to try it out, we're going to jump into Scratch and test some boundary cases. As you may have guessed, given the word boundary, right, that means like where is the edge, where is the line over what can happen and what can't. Boundary cases occur when the code isn't intuitive. The code is asked to do something that it can't do. All right, so you're trying to break the script or the code. Let's go take a look at the boundary cases in Scratch. All right, this is a quick script that will allow me to add the names of players. All right, so I'm going to add, my cat is, there we go. What is the player's name? All right, first player is going to be Bill. Next player is going to be George. Third player, Anne. Let's see, Susan. And let's have Keith. How's that? Just thought of those off the top of my head. All right, so my script did exactly what it was supposed to do. It was supposed to keep adding until my list had 5 people. All right, and so now it does. So now we can test some boundary cases. All right. So the question is, what is going to happen when we run this line of code right here? Insert thing, this is just a string, the computer doesn't know that it's not a name, at index 19 of, of players. All right, so let's find out what would happen. Well, nothing really happens, okay? And that's because I don't have 19. Okay, now if I wanted to play around with this, I could add spaces. Okay, I could add to the point where I had 19, and then I could run this line of code and it would insert it at 19. Okay, but I kind of manufactured that. And so I'm just going to delete all of these empty spaces that I created. So we know that we cannot use this command to insert something at an index that doesn't yet exist. All right, so we'll put that one over there. So the next question is, this we do have the ability, when we go to the tab that has all of the things we can do with lists, one thing is a Boolean. It's this giveaway hexagon shape. All right, so the question is, does the list players contain the word thing? Now, we're gonna have to make sure that the word thing does get into our list. So here we go. I'm just going to add it right in there. Okay, so now the word thing is in the list. But the question is thing with a capital T going to show up as the same as thing with a lowercase t? All right, so let's find out. Oh, and it is true. All right, so it tells us it is true that thing is there, even though we put it in with all lowercase letters. All right, so let's find out. What if I did this? What if I typed it in all caps? Does it still show? Oh, it's still true. Very interesting. All right, so what's going on, for example, if I typed, let's see, the word George in all lowercase, even though I know that George with uppercase G is in my list, it still shows up as true. All right, because typically what happens when you search through things in a list, a lot of times behind the scenes, that list is actually converted to either all caps or all lowercase. Okay, usually all lowercase. All right, so that's good to know, right? That you can have a little bit of forgiving capitalization, because we know people these days don't like to capitalize words quite as much. And so we've got a little leeway there. So if someone forgets to capitalize their first name, they will still be found, even if you search for it with a capital. All right, so we'll move that over there. All right. So the question is, this round or this rounded oval shape is supposed to be a value. I'm supposed to be able to use it wherever there's an oval, and I should be able to get some sort of value. And we said values can be everything from numbers to text strings or individual characters. So let's see what happens when I want to find out what the value of item 1 of players is. Oh, it's Bill. There we go. What's the value of item 2? It's George. What's the value of item 3? You guessed it, it's Anne. Okay, so I can look at the value and find out the value and use the value in my program of any item in the list, okay, at any existing index. Now, of course, if we did this thing in here where we tested 19 again, look, blank, okay, there is no item 19. All right, so it wouldn't necessarily return an error in Scratch, but it would not return a value. All right, so now we're done with that one.
So the last thing that we want to check when we're checking boundary cases, we want to make sure that we check a variety of value types. So we've checked text values, and those certainly seem to work fine. And we actually found out that they're not even case sensitive because they're doing some things behind the scenes to make sure that they catch those types of things. We can try some numbers. We could change this one right here. I've cleared out my list. It's just back to regular. And I'm just going to add the number 15 to see if it'll take a number. And sure enough, it will. It would probably stand to reason then that it would take an equation. And sure enough, and notice when I used the insert, it did insert it at the top of the list, and it pushed the previous value that was there, number 15, down a place. It takes words, text strings, it takes numbers as values. And the last thing that we want to check is, does it take Booleans? All right, so I've set up this Boolean here. We've got 3 less than 2, which of course we know should evaluate to false. And we're going to see if Scratch will insert the value of this Boolean at the top of the list. And sure enough, it does. And what I can do is even switch these values around. That is false. 3 is not less than 2, but 2 is less than 3. So if I change those values around and now try to insert again at the top, this time I've got true. Okay? And so we see that these are lowercase values when we use them from Booleans, and that's typically how it is. What I could do actually to even check this is I could check to see, is item 1 of players equal to true? And this time I'm going to try it with an uppercase T. And I'm going to check that, and sure enough, it evaluates to true. Even though I typed it in with an uppercase T and a lowercase t is really the value that's being returned, it is making those the same thing. All right, so in terms of boundary cases, we found that there really aren't any types of data that are not going to work in a list, and that Booleans are included in that.